sometimes sometimes people think functions are kind of mysterious and kind of scary, but actually we have that every day. It's our kind of our daily life experience. When you go to buy something, basically you say you don't mean you know the price, and then once you know the weight, and you know how much money you need to spend. Of course, nowadays you just scan it. You go, self-help. But in the old days, you had to do the calculation. But still, it's not that complicated. So we see that there is one way of looking at function is draw this a box, and we have input and output. And what comes in changes. What comes out also changes, right? It's not fixed. So when you go buy something, you can have different, you could have like 1 pound or 2 pound or 3 pound. You can still figure out on that. So this side, actually the input changes, and also output also change, but it has something to do with the input. So the output is, in a way, is dependent on the input. And of course, the output will depend on what kind of function we use inside here. But so we know something on one side, input changes, and in another word, is the varies. Its value changes. The value varies. So we call this a variable. Something which changes value. And also our output is also the variable. And we call this independent variable, because we can pick any weight. When you go to buy something, it's up to you. I mean, how many apples do you want to buy? But once you know how many apples you need to buy, then the price is fixed, because price, even though it changes, but it's changed according to the input. So this variable is called dependent variable. And now we have a convention. Convention is that we use X as the indeterminate variable. We use Y as dependent. So that's just convention. It doesn't, you don't have to use this, but most people using that. So we just go with it. So do you know what is a convention? Could you give a definition in your own word?
Well, a convention, could it be something to like resemble a certain variable, like a letter?
Well, talking about your daily experience.
Oh,
convention. When you say something is a convention, what do we mean by that?
I usually think it's like a show that my dad's working.
What's that?
I usually think it's a show that my dad's working.
Okay. So, for example, in this country, we drive on the right hand side, right?
Yeah.
Now, if we go to UK, United Kingdom, they're actually on the left hand side. Now, it can scare you the first time you go there. It definitely, you'll get scared. I remember the first time when I visited UK, after we landed in the airport, we just took a taxi, and that is really scary, because you are still used to that. You drive on the right hand side, and now you see the taxi drivers can drive you on the left. You can get scared, but then you get used to it. Because that's their way of doing it. Everyone drive on the left hand side. But here is on the left hand side. Here is right hand side. Now, which one is right or which one is wrong? That's not that's not a wrong and right situation. It's just like a convention. We call convention. Everybody agreed. We go on the right hand side, but it doesn't mean you are on the right hand side. You have you know, you are better than people who drive on the left hand side. You don't have that. So there are things in life. It has no moral value. It just like or another way to say it's a custom. Like that's how people does things, or how people wear wear the clothes. Now in the old days, that's you have to uh, girls and women have to wear skirts, but nowadays we don't have to. So that's just convention. So same thing when we say our independent variable is x, our dependent variable is y. That's also convention. And then we say that y is y depends on x. And we write as that y is, well, in English, y is a function. We call that y is function of x. But in math, we write as y is f of x. Good?
Okay.
So the f here just means function. X here, they put the inside, the parentheses just indicate this is the input. Now our y is output. Good?
Okay.
And we see that the example buying apples, and you can use a lookup table or just use a table. We have weight, we have cost. We write this as x because this is a independent variable. This is y. Okay, so we know that if x is £1, the cost is $2. £2 is $4. £3 is $6, and £4 is $8. So this is called table form. But we also have, in terms of algebra, we also have a function form. The function form is right as y equal to 2x. Good?
Okay.
So which means that if x is 1, is 2 times 1 is 2. If x is 2, 2 times 2 is 4. If x is 3, 2 times 3 is 6. X is 4, 2 times 4 is 8. Good?
Mhm.
So this is our simplest function. And this is something we call linear function. Okay. And later you understand why we call such thing, why we call that the linear function. Good?
Okay.
Okay. So now the function, once you have that, you basically know the relationship between the input and output. And so let's say y is 3x. So given that, you know, if you know the x, if x is 0, our y is 0. If x is 1, 1 times 3 is 3. X is 2, 2 times 3 is 6. It could be any number. Let's say x is 10, our y will be 30. Good?
Yep. Got it.
Okay. So now if we have a different form of the function, then the number will be different. We'll just try that here. Okay. Now, if we change that to y equals to 2x plus 3. So what will be the answer here when x is 0?
3.
Yes, it's 3. How about when x is 1?
5.
5. X is 2?
7.
Because 2 times 2 is 4 plus 3 is 7. X is 3?
12.
12. Are you sure?
Mm,
Because 2 times 3 is 6. 6 plus 3,
No, it would be 9. It would be 9.
9. Now, how about x is 10?
23.
Good. Are you okay, Morgan, on this one?
Yep.
Okay. So now we can change that to a different function. Y is equal to, say, 4x minus 5.
4x minus 5, and this is 0, 1, 2, 3, 10.
Yeah. So if x is 0, what is our y?
-5.
-5. Very good. X is the 1.
-1.
Yep. X is 2.
-3.
Perfect. And x is 3. 3 times 4.
7. Would it be 7?
7. Yep. Now x is 10.
35.
35. Very good. And so you can see that x is input, y is output. But if the function is different, then the relationship is different between the input and output. So function is really about a relationship between two sets of data. And this is kind of new because in the past, we're just dealing with, we don't dealing with the relationship between two sets of data. It's always, we're trying to solve something, give me something, I'll find the answer. Okay.
Two x plus 1.
Yeah.
Okay. Do you want Morgan to this one?
Sure, Morgan.
Okay.
So x is 0, 0 times -2 is still 0, right? Then 0 plus 1, then
Yeah.
it's 1. Okay. Then when x is 1, 1 times -2 is
That's
negative.
just 1.
So negative
That would not
plus
make,
1.
yeah, -2.
Negative what? -2 plus 1.
-1.
Yep. Now when x is 2, that's -2 times 2, which is -4. But then we have to add 1 to it.
That's negative. So that would be -3.
Right. And x is 3.
So -6.
So 2 times 3 is -6.
Mhm.
But don't forget we have this one here.
That's -5.
Right. Then x is 10. So -2 times 10 is -20. Then we plus 1,
-19.
-19. So that's basically what functioning is. And this is right now the function we're dealing with, we call the linear function. And later on, well, we will we'll study linear function first, but we're also going to study like we call nonlinear functions. Nonlinear functions. And well, in our life, a lot of times we're looking at linear function. If we go buy something, the unit price, that's a linear function. But we also see something which are not linear. For example, if you go store, you get like buy one, get one free deal, right? And so that's not a linear because you spend the same amount. Either you buy one or you get two. So that's one buy one, get one deal. And another example we see in real life is a pandemic. We call it virus infection. And virus infection is something we call exponential function, which started not that much, but it grow a lot. So I'll give you an example of those two different functions, so you have idea. Now, suppose you work for someone for 10 days. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we work 10 days. Now you have the option of two options to get paid. The first one is they give you $100 per day. Okay. And the other one is the first day you get $1, second day you get 2, third day you get 4. So each time you double it. 8, 16, 32, 64. So option 1, option 2, which option you will take?
2.
Okay, how Morgan, which option you'll take?
Yeah, well, they both seem pretty good. I mean, 2, it would always, if it's always going to double, then it means it would always increase. You wouldn't just start off with 100. But then again, you would start off very little, though.
Mhm.
So I think I might just stick with 1 and just get a steady 100.
Okay. All right. So basically, we're dealing with two kind of functions. This is called linear function. Each day we got increase the same amount, right? And that's a linear function. Each day you have the same amount increase. Because first day you got 100, second day you got 200, third day 300, right? Fourth day 400. So each day you get 100 more. So you have the same amount increase. But this is called exponential function. And because each day we double, good?
Okay, yep.
So first $3, right? 1 plus 2 is 7, plus 8 is 15, plus that is 31. Okay, so let's see which one we got better deal.
Excuse me, Dr. Ping.
Yep.
Can I share a problem that I once did in class that had to
Sure.
deal with this?
Sure.
So it was this thing. It was where you could either get $1 million in one day, or you could let $1 sit in the bank and double for 30 days.
Right.
So we did the math and we watched as like there's like getting $1 million like the first day versus letting it double.
Mhm.
By the end of the month, you ended up with like $6 million because you let it double.
Right. So that's the same idea here. One is a linear growth, another one is exponential growth. Okay.
Yeah.
So, and let's look. We actually, I think we have time to go through your example. But when you go increase on that one, so 1, 2, 4. So the total here is 1,000, right? On the top, 10 days, each day 100, 1,000. But 64, now this is what? This is a 1, 2, 3, 4, 5, 6, 7. 8 is 128. Then 9 is 256. Then on the 10th day, it's 512. And when you add all this together, it will be 123. That's the total.
1023.
Yep, 1023, 1,000, sorry, not 100, $1,023. And top one is $1,000. So even though starting at 1, 2, 3, 4, it's not that much, but once you get the 10th day, then you pass that. Good?
Yeah.
Yeah.
This is called exponential growth. And this is how the virus infection goes. So the virus infection, if we went through a pandemic, COVID, at first it's not that big deal. And all of a sudden it just goes up, kind of like explosion. Good?
Yeah, it's still like it's worse and worse and larger and larger.
Right. And okay, so look at your idea. We say that 1 million, right? Good.
Yeah.
And 1, then 1 million. And we have, say, 30 days, right? So at the end of a month, we got 30 times that. So it's 30 million. I mean, it's a big number. Okay, 30 million. But you look at 1, 2, and we just need to figure out how we come up with a function. So this is 1, 2, and 3. And this one actually goes like, if you look at it, there's 2 to the 0th power, right? This is 2 to the 1st. And this is 4, which is 2 to the 2nd. And then 5th day, 2 to the, 1 is 8. So 2 to the 3rd. Good. So this function is this function is y equals to 16 or 10 to the 6 times number of days, so the x. And this actually y is equal to 2 to the x minus 1. Okay.
Yeah.
Okay, so out of the 30th day, we got for the 30th day, our y is 2 to the 29th power. So
What? That's
so
crazy.
what is a 2 to 9th power?
Like $1 trillion.
Let's see. Okay, let me open up the calculator. I mean, sometimes, I mean, if you have a simple calculator, you'll get error out of this because they just couldn't handle that. Okay, I have the calculator here. Oh, where it go? Has to use the scientific one. So 2 to the power of 29. Okay, so what I got is, don't go, 536 million.
Oh, wow. Yeah, I got the same thing too.
Okay. That's it.
Yeah, that's
536 million. And
that is a lot more than the
right, this is
30
only
million.
30 million.
Yep.
Well, this actually, they are trying to show you, have you heard about compound interest?
Yes.
Compound interest. That basically, compound interest is a exponential function. So if you put money, like say now you put $1,000 into a mutual fund, that's you can invest in many stocks, and you just sit there. You don't need to do anything. You sit there for say 40 years, and you'll get pretty good return out of that.
Wow.
So 30 years, let me see, divide by 7. Normally 7 years it will double. That is, how about 6? So double is basically 2 to the 5th. 2 to the 5th is 32. So you got 32,000 when you get to 40 years old. So 1,000 plug in, you don't have to do anything. And yeah, so that's why important when you start working, you want to put money into the called retirement fund. So even though you don't think, oh, I'm still too young, but trust me, it goes very quickly. Before you know it, you'll be like 40 and 50. Okay, So that is, once you start working, put money into your retirement fund. And that, when you guys are like about 50 years old, you have pretty good chunk of money in your bank account. And that is the effect of exponential function. Or on the other hand, if you get student loan, that will actually work against you.
Get a what?
Student loan,
Student
like
loan.
you borrow money, okay?
Yeah.
That will work against you. And that's why many people like they couldn't pay it off because of the compounding, the interest is on that. So not only you pay interest on the amount you borrow, you also pay interest on interest. That's what called compounding. But if you put money into investment, not only you get interest on the capital, you also get interest on interest. Good.
So basically, student loans are a bad idea.
Oh, bad idea. Bad idea. I mean, or you like you get loan and you want to pay off quickly. So you don't want that compounding effect take place. You just pay it off in the first couple of years. I mean, that's fine. And also depends on what kind of major you go to. Some major, it's not bad. Like say, for example, my daughter went to Rose-Hulman. That's an engineering school. Good.
Yeah.
Now, their tuition is 40,000 because of private. Okay. Sorry, 40K. And their room and board is 20K. So
What?
yeah, 60K per year.
Wow.
Per year.
Oh my gosh.
But you have to think about that. What's their starting salary when you graduate? Their starting salary, the median is 1,000K, 100K.
That's only gonna fund you for like a year.
What's that?
Like if you get a starting salary.
Right, their starting salary, the median is 100,000. So comparison, this is not too bad, right?
Yeah.
I mean, it's a good, just think about investment. Or you can go to let's say a college and your student loan is 20K, which is very, very common. Good. And but depends on this your major. Like if we just call it liberal art, you know, in social study and English and history, things like that. And but your median salary is only around about 30K. Okay. So you can pay as much as here, but your starting salary is not as, I mean, it's way lower than this, right? So you also have to consider that which major you're going into, not just how much money you pay go to college. But nowadays, private school colleges is really at about, probably average is about 50K. And some are more, some are less. And the public college, like Purdue and IU, is around about that.
So like Purdue is like, what you say, right above that?
Purdue is about that, about 20K. Yeah.
Okay. Wow.
Yeah, Purdue has a pretty good engineering program.
Yeah. I'm trying to become an engineer myself.
That's good. Yeah. What kind of engineering?
I don't know. I really love engines and airplanes and cars and trains and like all things that move. So I'm kind of like, I've kind of stumped because I want to learn how to do all those things.
Right. You eventually have to pick a career. Yeah, Purdue is pretty good, their engineering program. And also, when you go to those like Purdue, the first year, you don't have to pick a major. I mean, you're just engineering. You don't have to pick which engineering you go into. And then just give you the first year experience, and then you decide where to go to. Yeah, Purdue definitely is a good school. And if you are interested in like astronaut and going to Mars and all that, Purdue is the number one in the world. Now, Purdue actually graduate a lot of astronauts, right?
No, I didn't.
Yeah. Yep.
Wow, that's
Yeah. Known
amazing.
for that.
Yeah,
Mhm.
that's amazing.
Yeah, Purdue is a good school. Difference is that Purdue is public and Rose-Hulman is private. Rose-Hulman is very small. Purdue is big, so which means that when you go to Purdue, you probably won't see professor. I mean, most of the classes are taught by graduate student, but when you go to Rose-Hulman, it's private and small, and they are taught by professors. There is a plus and positive and negative. So but anyway, when you get there, you can make a choice. And make sure you got very good SAT or ACT scores.
Yeah.
Mhm.
I'm shooting for that.
Good. All right. Okay. I'll see you guys next week. Okay.
See ya.
Bye.
Bye.
Bye. Thank you.
You're welcome.